Hello, can you hear me?
Yes, sir.
Okay, we look at this problem. We were discussing it in the last class. So the mistake that we were making is that we were trying to count from below. There were many cases that were coming, right? Do you understand what I'm saying?
Hello, sir.
Can you hear me?
Yes, sir. Now I can hear you.
So in the last class, when we were trying to solve this, we were making a mistake because we were trying to count from the bottom. Like we were saying f of 1 is 1 and so on, right?
Yeah.
Then the
Yes.
problem was that every step there were two choices.
Yes.
F of 1 could be a single element set or a double element set, and things like that were happening, right?
Yeah.
And
Yes.
because every step there were two choices, it is difficult to count if you try to build it like that. So, first of
Mm.
all, here, because it is a one-to-one function, and because of this condition, we know that whenever you take f of 1 has to be a subset of f of 2. It has to be a subset of f of 3, proper subsets, right?
Yes. Yes.
So that means the number of elements in all of this is different, right?
Yes.
So you can have this as 1, 2, 3, and this as 6 element set, or you can have this as 0, and then this can be basically 1 or 2, and this can be 2 or 3, right?
Yes.
So that was the problem, that when we were trying to count how many choices are there, we can't make the thing easily, because if you choose one here, then all of the rest of the things depend on that, right?
Yes.
And if you choose two, then everything else is three, four, five, six.
Yes.
So the way to count it is try to build it from the top, from this side. Do you
Mm.
understand what I'm saying? So
Yes, sir.
we'll try to count it from there. So we'll say case one is when f of 6 has 6 elements. So if it has 6 elements, then obviously there is only one way to do that, right? From the power set.
Yes.
The power set of S has one element called S itself, right? So the total number of elements
Yes.
in the power set is 64, but only one element is 6 element subset. So f of 6, there is only one way.
Mm.
F of 5, now remember, f of 5 has to be a subset of f of 6, right?
Yes.
And f of 6
Yes.
right now is the full set itself. And f of 5 cannot be having less than 5 elements. Like
Yes.
it can have 4, but for now we are taking the case where f of 5 has 5 elements, right?
Yes.
If f of 5 has 5 elements, then how many ways to make that subset? How many subsets are possible? Tell me. These 5 elements are subsets of f of 1. F of 1 was S itself.
Yes.
So how many ways can we pick f of 5?
Sir, we should. It should be 61.
Right. 6C1, because one of them you have to remove.
Yes.
So we can decide which one to remove. That there are 6 ways to remove it. So there are 6 different 5 element subsets, right?
Yes.
Okay, then f of 4, let's take, you have to take 4 element subset of f of 5,
F of
right?
5.
Why f of 5?
Yes.
Because we have to say no that f of 4 is subset of f of 5.
Yes.
So whatever you selected here, whichever 5 elements, you have to pick 4 from them, right?
Yes.
So how many ways can we do that? 5C1, right? or
5C1.
5C4, the same thing.
Yes.
Out of those 5 from here, you select 4, right?
Yes.
Which is 5 only. Then f of 3, similarly,
Mm.
it has to be a 3-element subset of f of 4
F
itself.
of 4.
So now notice that there is no confusion.
Yes.
Every time we are making the new lower one as a subset of the higher one, right?
Yes.
So this will
Yes.
be obviously 4C3, so 4, and f of 2 would be 2-element subset of f of 3, so it will be 3C2 or 3, and f of 1 will be a 1-element subset of f of 2, right? So there will be 2 ways,
Yes.
correct? So
Yes.
there are 2 ways if f of 2 is a 1-element subset, and there is one additional way where it can be null set also, f of 1, right?
Yes. Yes.
So 2 ways for it to be directly a subset of f of 2, but also there is a null set also, it is possible, right? So total number of
Yes.
ways is 3, right?
Yes.
So basically now we are getting total number of ways in this case is coming out to be 1 into 6 into 5 into 4 into 3 into 3, right?
Yes.
So you're getting 13, 4, 120, 360, 1080. This many 1 functions we are making in case 1, right?
Yes. Yes.
Now we have to look at other cases. For example, here f of 6 had 6 elements, f of 5 had 5 elements, f of 4 had 4 elements, and like that it was. The only choice was at f of 1, which
Yes.
could have 1 element or 0 elements, right?
Yes. Mm.
Remember, we have gotten 1080 functions like this. Now we'll do case 2. And in case 2, again, I will say now f of 6 I will not take as a 6-element subset. I will take it as a 5-element subset of power set. Basically, 5-element subset of S. So it will become 6C5 or 6 ways, right?
Yes.
So basically, I am making f of 6 as a 5-element subset, right?
Yes.
Earlier, in the previous case, we had done f of 6 as 6-element subset, right?
Yes. Yes.
Now we have started reducing, like we are not taking f of 6 as 6-element, we are taking f of 6 as 5-element because I want f of 1 to be guaranteed now null set, right?
Yes.
Because now f of 5 has to be 4-element, right?
Yes.
But that 4-element has to be a subset of what? It has to be subset of f of
F of 1.
6,
F of 6.
right?
Yes.
Because we have to guarantee that every lower output is a subset of the higher output, right?
Yes.
So
Mm.
out of these 6 of them, no, out of the 5 elements here, we have to select any 4. So 5 ways,
Yes.
right?
Yes.
5C4. Then from here, 3-element subset of f of 5, right?
Yes.
So that will be done in 4 ways. And then 2-element subset of f of 4. So that will be done in 3 ways, right?
Yes.
And finally, 1-element subset of f of 3, right?
2 ways.
So that
Yes.
will be done in 2 ways. And f of 1 is guaranteed to be null set now, right?
Yes.
So this
Mm.
is different from case 1. Case 1, what was happening? F of 6 was 6, this was 5, this is 4 and all, right?
Yes.
So this is different. So now we have 6 into 5 into 4 into 3 into 2, right? So there's a
Yes.
30, 120, 360,
720.
720, right? So this
Yes.
was case 2. Now case 3, again, slightly similar. But again, we'll keep changing it like that. So case 3 is f of 6, let's take, is as S itself. right?
Yes. Mm.
But f of 5, we will take f of 5 as 4 element. Remember, in case 2, we took f of 6 as 5 element and f of 5 as 4 element and so on, right?
Yes.
But here we are taking f of 6 as 6 element. And this here is the gap, 6 to 4. Do you understand what I'm saying? Look at all the cases we have done so far. This was case 2. This was case 1 was this. F of 6 is 6. F of 5 is 5. All of them had their equal number, right? Till f of 1 was 1 or null set, right? Can you hear me right now? Hello? Hello?
Hello, sir.
Can you hear me right now?
Yes, sir. The network issue there.
So what I want you to understand is how the cases are different from each other. Case 1 was every element had equal number and only last one had 1 or 0, right?
Yes.
Case 2, every element had 1 less than its number, see?
Yes.
Correct? Case
Yes.
3 is different. I'm doing like this. F of 4 has 3 elements. F of 5, F of 3 has 2 elements. F of 2 has 1 element and F of 1 has null. So notice that there is a
Yes.
gap here. This is 6 elements, right? Correct? And in each step,
Yes.
this can be done in only one way, but this can be done out of those 6, you have to select 4, right?
Yes.
Do you understand? You have to take the subset of that only. So 6C4, which is
Yes, sir.
15, right? And out
Yes.
of these 4, you have to select 3 here. So 4 ways. And out of these 3, you have to
Yes.
select 2 here. So 3 ways. And out of these 2, you have to select 1. So 2 ways, right?
Yes.
So you should understand that each case is different. Can you see that?
Yes, sir.
So how many are coming here? 15 into 4 into 3 into 2, right? So it is
360.
360 here. It was 1080 here. It was 720 here, right?
Yes.
So total is coming out to be 720 plus 360 is 1080. So total so far is 2160, right?
Yes. Yes.
Now we will look at case 4. Case 4 is also different, but now notice what I will do in case 4. So I will write it here. Case 4, you start with f of 6 as 6 element, f of 5 as 5 element, but f of 4, you will not take 4, you will take 3. Do you understand? The
Yes,
gap
sir.
is happening here. And then f of 3 will be 2, and f of 2 will be 1, and f of 1 will be null, right?
No.
So this is
Yes.
also different from everything we have counted so far, right?
Yes.
So now this is only one way. F of 5, out of this, you have to select 5. This can be done in 6 ways, right?
Yes.
Now, out of those 5, you have to select 3, right?
Yes.
Correct, no? So
Yes.
5C3, so 10 ways, right?
Yes.
And then after that, out of those 3, you have to select 2, so 3 ways. And out of those 2, you have to select 1, so 2 ways, right?
Yes.
So you are getting 6 into 10 into 6. So basically 360, right?
Yes.
Similarly, case 5, you should understand the pattern by now.
Yes.
In case 5, I will do f of 6 is 6, f of 5 is 5, f of 4 is 4, but f of 3 is not 3, 2.
2.
right?
Yes.
So f of 6 is 6, f of 5 is 5, f of 4 is 4, f of 3, however, is not 3 but 2. Now, f of 2 is 1 and f of 1 is null,
Yes.
right? So this can be done in one way, this can be done in 6 ways, right? This
Yes.
can be done subset of it 5 ways,
Yes, teacher.
but now here 4C2, right?
Yes.
So 6 ways, and here out of those two, 1, so 2 ways, right?
Yes.
So you're getting 36 into 5, 180 into 2, 360 here also, right?
Yes.
And I think there is one final case now, which is f of 6 is 6, f of 5 is 5, f of 4 is 4, f of 3 is 3, but f of 2 is not 2 but 1,
Yes.
and f of 1 is null, right?
Null. Yes.
And now you'll get again 6 ways for this, right? One
Yes.
way for this, 6 ways for this, then 5 you have to select 4. So 6 into 5, 4 you have to select 3. So 4. And out of those 3 you have to select only one. So 3 ways after that, right?
Yes.
And that's it. So it is going to be 30 into 4, 120 into 3, 360 again, right?
Yes.
So notice that 360, 360, 360 have to be added to this. So 1080 have to be added, right?
Yes.
So you'll get 3240. And now think about it, there is no further case left.
Mm.
Why? Because we have done f of 1 is null set, all the cases we have done, right?
Yes.
We also did case 1 where everything was equal except f of 1, which could be 1 or null,
Null. Yes.
right?
Yes.
So basically, the thing is that from the beginning, you have to, if you count from the bottom, it is much harder
Yes.
because you don't know how to split the choices. But if you
Mm.
count from the top, from f of 6 and all, you start thinking from there, then every step you have to take subset of the previous one, right?
Yes.
So which makes it very easy. You don't have to worry about so many choices then.
Mm.
Do you understand what I'm saying?
Yes, sir.
Do you have any other questions that have been not solved?
Oh, no, sir.
Okay, so then we will do some questions. Let's look at this one. Okay, so question is this: let A is the set 1, 2, 3, 4, 5, and B is the set 1, 2, 3, 4, 5, 6. You have to find the number of functions from A to B satisfying f of 1 plus f of 2 is equal to f of 4 minus 1. You have to count the total number of possible functions here. Basically, you have to satisfy this condition somehow, right? f of 1 plus f of 2 plus 1 is equal to f of 4, right? This condition has to be true always, no? Do you understand what I'm saying right now? Can you hear me? Can you hear me?
Yes, sir.
You have to find the number of functions which satisfy this condition, right?
Yes.
So think about it. We have f of 1 plus f of 2 plus 1 is equal to f of 4. Now,
Hmm.
looking at the two sets, what is the maximum value of f of 4?
6.
Right. So we know already that f of 4 is less than equal to 6, no?
Yes.
So from there we can say that that means f of 1 plus f of 2 plus 1 is less than equal to 6, right?
Yes.
So you are getting what? F of 1 plus f of 2 is less than equal to 5, right?
Yes.
That is the situation. So now you have to take different cases here. For example, we can take cases like this. Case 1 is f of 1 is 1, right? That is the lowest possible value.
Yes.
Then in that case, f of 2 can be 1, 2, 3, 4, right?
Yes.
F of 1 is 1, f of 2 can be anything from 1, 2, 3, 4, because then only you can add it and be getting less than equal to 5, right?
Yes.
So how many ways are there? 4 ways,
4.
right?
Yes.
Case 2 is f of 1 is 2, then f of 2 can be 1,
1,
2, and
2.
3, right?
Yes.
So 3 ways here, correct?
Yes.
F of 1 is 3, then f of 2 can be
1
1
and 2.
and 2. So 2 ways here. And f of 1 is 4, then f of 2, in that case has to be only 1, no?
1. Yes.
So only one way in this case, these 4 cases, right?
Yes.
So now for either of these 4 cases, we still have to decide what will be f of 5 and f of 6, right? No, not f of 6, f of 4 and f of 5, right?
Yes.
F of 4, we know that only thing we know is f of 4 is less than equal to 6, right?
Yes.
Correct.
Yes.
So f of 4 has 6 ways, no? Let me think. 1 second. See, once you have fixed a particular value of f of 1 and f of 2, you will get the value of f of 4, no?
Yes.
Do you understand what I'm saying?
Yes, sir.
So in all of these cases, f of 1 is 1, you get f of 2 is 1, then you get the value of f of 4 as 3, right?
Yes.
In this case also, if it was 2, then you would get 2 plus 1 plus 1, 4. right?
Yes.
Correct.
Yes.
So basically, f of 4 is completely determined by the values of f of 1 and f of 2, right?
Yes.
Do you understand what I'm saying?
Yes, sir.
So if there are 4 ways to do these, there will be 4 different values of f of 4, right?
Yes.
We don't have to count that then,
Yes.
correct? Only
Yes.
thing we have to count is f of 5, about which we know nothing. It can be anything from 1 to 6, so 6 ways, right?
Yes.
Do you understand?
Yes, sir.
Okay. And then, is there anything else, any other case? So,
Sir, f of 3.
f of 3, we have not yet said anything. That also can be done in 6 ways, right?
Yes.
F of 4, we don't have to count because it's already decided by these two, right?
Yes.
So the total number of ways would be, for this case, it will be 4 into 6 into 6, right? For 3 and 5.
Yes.
This is for f of 3, this is for f of 5, and this counts everything, f of 1, f of 2, and f of 4, right?
Yes.
Do you understand what I'm saying?
Yes, sir.
Similarly, this will be 3 into 6 into 6, no? 2 into
Yes.
6 into 6, and 1 into 6 into 6, right?
Yes.
So ultimately, all of them have to be added, all the different possibilities. So you'll get 4 plus 3 plus 2 plus 1. So that is 10 into 6 into 6, right?
Yes.
So answer is 360. Do you understand what we have done?
Yes, sir.
So basically, we are not doing anything very difficult, and there was no extra condition on the problem other than this.
Yes.
So we are just taking the possible values. We know f of 4 is less than equal to 6. So we know f of 1 plus f of 2 will be less than equal to 5. And then we took 4 cases for that, right? And
Yes.
every time we know f of 1, f of 2, f of 4 is already fixed. So we don't have to worry about that.
Yes.
F of 3 and f of 5, there was no condition. So there are 6 choices for both.
Yes.
Is it clear?
Yes, sir.
Okay. Then let's look at another problem. Okay, so the question says, if the function f, which is defined from minus infinity minus 1 to a comma b, with the definition is f of x is equal to e power x cube minus 3x plus 1, is 1 to 1 and onto, then you have to find distance of the point P 2b plus 4 comma a plus 2 from the line x plus e power minus 3y is equal to 4 is how much? So second part of the question will be easy if you can find a and b, right?
Yes.
That is just a simple distance of a point from a line, right?
Yes.
The main thing in the question is to figure out what is a and b, right?
Yes.
That you have to figure out from this fact and the fact that it is 1, 1 and onto, right?
Yes.
What is the meaning of onto function? Do you know onto function meaning?
So it will have only one pre-image in the set A.
No, that is 1,
Means
1
all the
function.
elements will be linked.
What you just, it will have only one pre-image in set A. That is 1, 1 function definition, no?
Okay.
Do you understand what I'm saying?
Yes, sir.
What you said was definition of 1, 1. I am asking onto. What is the meaning of onto? This is set A, this is set B.
Range and codomain will be same.
Right. So range is equal to codomain. That means in set B, there is nothing left over, right? Extra. Everything in set B has to be linked to something here, right?
Yes.
It should not be that there is one element here with no links, right? If there is anything
Yes.
left over in set B, that would make it an into function, correct?
Yes.
So right now range is equal to codomain, that is the information. So this set, this is known as what? This is actually codomain, no?
Yes.
So all we have to do is find the range of this function, right?
Yes.
If we can find the range, then we can say that that will be equal to codomain, right?
Yes.
And if you can do that, then you will know that A and B values are what? Correct?
Yes.
Okay, so our job is to find range of the function f of x is equal to e power x cube minus 3x plus 1. Okay,
Yes.
so think about it now, range. Notice also that the domain is from minus infinity to minus 1, right?
Yes.
So it's not like all the elements in the x can be put. Only from minus infinity to minus 1 can you put the x, right?
Yes.
So think about that carefully and think of the range like that. Usually the graph of e power x function is always positive, right?
Yes.
E power x is always positive. So this quantity will always be positive only, right?
Yes.
But we have to understand what happens to that x cube minus 3x plus 1. Then only we can predict the values. X cube minus
Yes.
3x plus 1 when x goes from minus infinity to minus 1, right?
Yes.
So if you think about it, let's call it g of x. Now you should know that this is a cubic and cubics, like we can do one thing, we can do a derivative of this to find where it increases or decreases, right?
Yes.
Do you know the fact that differentiation will tell us the slope of the curve and all?
Yes, sir.
So if you do derivative, you'll get 3x square minus 3, right?
Yes.
So notice that it is 3 times x minus 1 and x plus 1, right?
Yes.
So if you plot it below minus 1 only we need to put the x, right?
Yes.
If it is always below minus 1, this part is negative and this part is also negative, no?
Yes.
Do you understand what I'm saying?
Yes, sir.
Both the terms are negative, so the derivative overall will be positive, right?
Yes.
Do you understand that g dash x is overall positive?
Yes, sir.
So if it is an overall positive derivative without ever becoming negative, then that means g of x is always increasing, right?
Increasing. Yes.
Because slope of the function is always positive. So it must be increasing function, right?
Yes. Yes.
So now what we have to think of is what is the lowest possible value. When minus infinity, g of x is also going to be minus infinity, right?
Yes.
Do you understand that g of minus infinity is tending towards minus infinity? And it is always increasing till here, no?
Yes.
So what is the highest value? The highest value will happen at -1, right?
Mm.
Because the function is always increasing. So highest value of g of x will come at -1, no?
Yes.
So it will be -1 plus 3 plus 1. So value is equal to 3. Correct?
Yes.
So now we know that this thing g of x is tending to, g of x goes from -infinity to 3, right?
Yes.
But what was f of x? F of x was e to the power g of x, right?
Yes.
Do you understand what I'm saying?
Yes, sir.
These values are -infinity to 3. So f values will be, the lowest will be e power -infinity, which is 0, and the highest will be e power 3, right? Is it clear what I'm saying right now?
Yes, sir.
Because we have found the how the power of it is varying, we can now predict what the function f of x will take, no?
Yes.
So it will be e power -infinity to e power 3. So that is 0 to e power 3. Correct?
Yes. Yes.
That becomes the range of our function, 0 to e power 3. And basically now from here we can say a is
Yes.
0 and b is e power 3, right?
Yes.
Because range was equal to codomain because it was onto function.
Mm.
Now that we have found this, we have to find distance of point P, which was 2b plus 4, comma a plus 2, where a is 0 and b is e power 3. So the point is becoming 2 e power 3 plus 4 and 0 plus 2, so 2, right? And distance from this point
Yes.
to the line equation was given as x plus e power minus 3y equals 4, right?
Yes.
So distance formula, you will just put the point in the line equation. You will get 2 e power 3 plus 4 plus e power minus 3 into 2 minus 4 modulus divided by root over 1 plus e power minus 6, right?
Yes.
Notice that this 4 and this 4 gets cancelled and you are getting 2 e power 6 plus 1 by e power 3, and here you are getting 1 plus e power 6 by e power 6, right?
Yes.
So this becomes e power 3 cancels here and this becomes cancels here and you're getting 2 root over 1 plus e power 6. Correct?
Yes.
That becomes your answer. Do you understand how we have gotten it?
Yes, sir.
So the key thing here was to understand what 1, 1, 1, 2 means and how did we find the range? We found the range by noting that the function is always increasing because it was e
Yes.
power something and that something was always increasing. How did we get
Yes.
that? By taking derivative and seeing the slope of that thing, right? Gx.
Yes.
I hope you are understanding everything.
Yes, sir.
Okay. Now, this question. F is real minus bracket 2, 6, 2 real, and it is defined as f of x is equal to, oh, 1 second. Right. F of x is equal to x square plus 2x plus 1 divided by x square minus 8x plus 12. You have to find range of f. When somebody says something like this, what does it mean?
2 and 6 will not will be the
Ah,
domain.
because obviously you can see that 2 and 6 are roots of this.
Yes.
So find the range of this function basically. Do you know the standard method to find range of such situations?
Sir, x square plus 2x plus 1 upon x square minus 8x plus 12 will be real, so we will put it equal to y.
And
And
you'll make
then,
a quadratic in x, right?
yes,
So
and that
you'll
the,
cross multiply and do a quadratic on x, right?
yes,
Yx square minus 8xy plus 12y is equal to x square plus 2x plus 1. And you will do y minus 1 x square plus, no, minus y minus 2x or simply x, let's say. You will get 8y plus 2, right?
yes,
And plus 12y minus 1, right?
yes,
This is a quadratic and x is real here, right?
yes,
So we can say that the discriminant of this quadratic has to be greater than 0, right?
yes,
So we'll say discriminant greater than equal to 0 for this. So that will come 8y plus 2 whole square minus 4 into y minus 1 into 12y minus 1 is greater than equal to 0, right?
yes, yes,
And now you'll get a new quadratic from here, right?
yes,
Notice you can take 2 common, it will become 4 outside and 4 will cancel. So you will get
mm,
here 4y plus 1 whole square minus y minus 1 and 12y minus 1 greater than equal to 0. You'll get
yes,
16y square plus 1 plus 8y minus 12y square minus 12y minus y. So minus 13y plus 1 greater than
yes,
equal to 0. So you're getting finally 4y square minus minus, so plus 21y and plus 1 minus 1 is greater than 0, right?
yes,
So from here y common 4y plus 21 is greater than equal to 0, and we can now do wavy curve for this.
yes,
So you will get minus 21 by 4 and 0, and it should be above it or it should be below this, right?
yes,
It cannot be between these two.
yes,
So our answer will be minus infinity to minus 21 by 4 union 0 to infinity. Correct?
yes,
This is a standard problem solving method. So you should know this whenever there is a rational function like this, right?
yes,
You have seen it in your Allen book and all, no?
yes, sir.
Okay. Right. The next one. One second. Right. Okay. This question. The number of functions f from 1, 2, 3, 4 to the set here a belonging to z such that mod a is less than 8, satisfying f of n plus 1 by n f of n plus 1 is equal to 1 for all n belonging to 1, 2, or 3. You have to find the number of such functions. Do it carefully. First of all, try to understand what this set means.
Yes, sir.
This set here. basically a can be an integer such that mod a is less than 8, right?
Yes.
It is actually less than equal to 8. So basically
Mm.
this set will be from -8 to 8, no?
Yes.
-8 is less than equal to a less than equal to 8. And
Mm.
f is from 1, 2, 3, 4 going to this set. Correct?
Yes.
So that automatically tells us that output is also some integers, -8, -7, -6 till +8.
Yes.
From 1, 2, 3, 4. And now you have to make sure that this condition is true for n is 1, 2, 3.
Yes.
So then since the only 3 values are there, we can actually write each of them separately by taking n is equal to 1, n is equal to 2, n is equal to 3, right?
Yes.
So n is equal to 1, if you do, you get f of 1 plus f of 2 is equal to 1, right?
Yes.
And the second condition is 2 if you put f of 2 plus half of f of 3 is equal to 1, right?
Yes.
So this
Yes.
can be rewritten as 2f of 2 plus f of 3 equals 2. And finally, when you put 3, you get f of 3 plus 1 by 3 f of 4 equals 1. So this can be written as 3f of 3 plus f of 4 is equal to 3.
Yes.
Correct?
Yes.
So you have 3 equations now. This equation, and this equation. Okay. So we can try to get a stronger condition by trying to eliminate some of the variables. For example, f of
Yeah.
2 and all we can try to remove. No, from here you can put it in here, right?
Yes. Mm.
So let's say f of 2 is 1 minus f of 1, and if I put that here, I'll get 2 minus 2 times f of 1 plus f of 3 is equal to 2, right?
Yes.
We are getting 2 gets cancelled, you're getting f of 3 is equal to 2 times f of 1,
Yes.
correct? And
Mm.
now this f of 3 value we can put here, no?
Yes.
So we'll get what? We'll get 6 times f of 1 plus f of 4 is equal to 3, right?
Yes.
Do you understand?
Yes, sir.
So f of 4 is coming out to be 3 minus 6 times f of 1, correct?
Yes.
We also have gotten things like f of 3 is 2 times f of 1 and so on, correct?
Yes. Yes.
So notice from here, we can decide what are the possible values that f of 4 can take, because I know already that all the f values are between -8 and 8, right?
Yes.
So I can say f of 4 will be between -8 and 8. And from there, we can say -8 is less than equal to 3 minus 6 times f of 1 less than equal to f of 8. Not f of 8, it is just 8.
Yes.
So simplifying it a little bit, you get -11 less than equal to -6 f of 1 less than equal to 5. And when you multiply by minus sign, the inequality will reverse the sign, right?
Yes.
Like this. And you are getting f of 1 is between -5 by 6 and up to 11 by 6, right?
Yes.
But isn't f of 1 supposed to be an integer?
Yes, sir. It should be integer.
So f of 1, the only integers between these two are 0 or 1, right?
Yes.
Sure, no?
Yes.
Okay. So case 1 is f of 1 is 0, right?
Yes.
If f of 1 is 0, automatically from the first equation, which was f of 1 plus f of 2 equals 1, we get f of 2 is 1, right?
Yes.
And now f of 2 is 1, so f of 3 is from f of 3 is actually 0, right?
Yes.
Why? Because 2 times f of 1, no, f of 3 is.
Yes.
And from the third equation, if f of 3 is 0, f of 4 is 3, right?
Yes.
Correct?
Yes.
And notice that the function had only 4 inputs, no?
Yes.
1, 2, 3, 4. So we have found all the possibilities, right?
Yes.
So this is one function. One function we are getting in case 1, right?
Yes.
Similarly, case 2, f of 1 is coming out to be 1. In that case, f of 2 is 0, right?
Yes.
And f of 3 is 2 times of f of 1, so 2. And f of 4, if you solve from the third equation, you get minus 3.
Yes.
And ultimately, these are the only two cases possible because these are the only two possible values of f of 1,
Yes.
right?
Yes.
So, what was the main idea in the question here? By using the condition in the problem, we got three equations. F of 1 plus f of 2 is 1. 2f of 2 plus f of 3 is 2. And 3f of 3 plus f of 4 is equal to 3, right?
Yes. Hmm.
Now, we did what? We eliminate one by one all the variables. So, eliminate f of 2 first. From there, by using f of 2 is equal to 1 minus f of 1, right?
Yes.
We put that here. We got f of 3 from there is equal to 2 times f of 1.
Yes.
And then we eliminated that from this equation. And we got f of 4 as 3 minus 6 times f of 1, right?
Yes.
And we know additional information that any value of f of n will be between minus 8 and 8.
Yes.
So from there, putting that inequality, we get f of 1 values have to be between minus 5 by 6 and 11 by 6, right?
Yes.
And that gives us two possible values, two values. And for those two values, you can make two functions.
Yes.
You can find the other values of f of 2, f of 3, f of 4.
Hmm.
Is it clear?
Yes, sir.
What are they doing right now in class and all for you?
Sir, today they will complete the function. Means periodic is left and
Hmm.
then it is complete.
Inverse and all, basically, they have discussed briefly.
Yes, sir.
Okay, so just do as much. So don't wait for them. Do the Allen exercise.
Yes, sir. Sir,
They,
I am having one doubt.
hmm,
Means it is not the problem, but here a symbol means the one
hmm,
symbol is F plus G. So how I
hmm.
can solve that?
F plus G, if they're writing it like this, F plus G, they mean F plus G of X.
Yes, that only.
So this one, you just have to think of it as, wait, they're writing it like this.
Yes.
Show me a picture of what is written.
Okay, sir.
In the book, wherever it is, show me a picture of that.
Sir, I send the photo of it.
So f plus g, there's a piecewise defined function. So technically now you have to think about near 1, what is f and what is g, right? So think about it. If you look at the f function, it was x plus 7 for x greater than equal to 3, but it was less than something else before, right?
Yes.
And similarly, g also is x plus 6 in that region, right?
Yes.
So f plus g will be the function, that part of f plus x plus 6, right?
Yes.
Do you understand what I'm saying?
Yes,
The
sir. Means
part of,
there is written x plus 7 for x greater than equal to 3 for f of x. And in g of x, it is written x square plus x plus 2 for x greater than 4. So if I mean to say that x should be greater than 3, then f of x plus means f plus g. That means x plus 7 plus x square plus x plus 2.
right, but it has to be greater than 4, not greater than 3 for that.
Okay.
Because x square plus x plus 2 happens greater than 4, no?
Yes.
In the first part, when we are saying f of f plus g of 1, what is f of x when x is less than 3? What is the written there?
X square minus 3x plus 4.
So you will say x square minus 3x plus 4 because 1 is less than 3, and x plus 6 because again it is less than 4, right?
Yes.
1 is less than 4. So this function will become what? X square minus 2x plus 10,
Yes.
right? And now you will do 1 minus 2 plus 10, it is 9.
Mm.
So first option is coming, right?
Yes.
For 3.5, f minus g when you are checking, f will be x plus 7, but g will be what? X plus 6.
Yes.
Do you understand?
Yes, sir.
It will be x plus 7 minus x minus 6. So it will be clearly 1 only always, right?
Yes.
F into g for 0. So for 0, you will take the x square minus 3x plus 4 for f. But for g, what will you take? X plus 6.
Yes.
And when you put 0 value, notice 0, 0, 4 and 0, 0, 6. So 24 is coming.
Mm.
All ABC so far is everything is right. Now f by g of 5. So for 5, you will take x plus 7. And for g, you will take x square plus x plus 2. Right?
Yes.
And on this, you will put the value 5. You'll get 12 by 25 plus 5, 30 plus 2. So 12 by 32, which is 3 by 8, which is wrong.
Yes.
Do you understand what we are doing?
Yes, sir.
This is not the same thing as composition.
Mm.
This is just combining two functions directly by using their definition. But you have to be careful about which part, what is f and what is g.
Yes.
So basically, what you should do is try as much of the exercise as possible. Let's try to finish it in the next couple of classes.
Yes.
If you try the exercises and come with the doubts, we'll clear everything and solve it and finish it off. Right?
Yes, sir. Yes.
So try that for Monday's class.
Okay, sir.
Okay, that's all for now then.
Thank you.
Mm.